Okay, we're on to section 4.9, and what we're going to do in 4.9 is we're going to take all the rules of differentiation that you've studied so far, and we're going to start combining them. You've now learned all the rules you'll need to know to do differential calculus. The only exception are what are called the transcendental functions, sine, cosine, tan, and the logarithmic and the exponential function. But every other function that you will encounter in a calculus class, you've now taken the rules for differentiating them. So the good news is you've got all those rules in place. The rest of it now is just, as I've indicated here, it's just practice, practice, practice. Being able to differentiate a function is the key to calculus. Later on, when we get into the applications, we don't want to be bogged down with the process of finding a derivative. We want to be concentrating on what to do once we have that derivative. So my advice is to just practice, practice, practice. The more questions you differentiate, the better off you're going to be when it comes to the chapters that come up further later on in the course. So what I'm going to do here is just take you through a few questions, explain to you how they're done. The first question I've shown you is y equals 2x cubed divided by 4x minus 1 all to the fourth. Now, something that I'll talk about is the dominant rule. If you look at this question, there's all kinds of things happening. I mean, if you look at the top, 2x cubed, that's a power rule. If you look at the bottom, we have the general power rule. We have a function being raised to a power. You know, we saw that last unit in with the chain rule. Plus, we have a quotient. We have a function being divided by a function. What you have to do is identify what's the dominant rule. If you look at the entire question, what's dominating? And what's dominating here is that we have a quotient. We won't actually encounter the power rules until we move into the quotient rule itself. So the dominant rule here is the quotient rule. And the quotient rule says that if you have a function divided by a function, that the way you differentiate it, so dy dx indicates that we're taking a derivative, is equal to, now you start by taking the derivative of the numerator. This is what I mean by layers. So now if you look at the numerator is just a power. We don't have to worry about a quotient, we don't have to worry about anything else. We just have a power being multiplied by a constant 2. So the rule is that we just simply multiply the exponent out front and subtract 1. So the derivative of 2x cubed is going to be 6x squared. That's going to be multiplied by our denominator because that's what the quotient rule tells us to do. So we're going to multiply by 4x minus 1 to the fourth. The quotient rule then indicates to subtract, and then we're going to take the derivative of the denominator. Now when you look at the denominator, we have an entire function being raised to the 4. It's a composite function. And so it's our chain rule, but we learned a shortcut for that. It's called the general power rule. So what we do is we treat this like it was a power. We take the derivative of what's inside here by multiplying the 4 out front. So we go 4 times. We don't do anything inside. We just leave it alone. Subtract 1 from the exponent. So that's our power rule, but we're using the general power rule, which says then we have to multiply by the derivative of what's inside with respect to x. So we have to multiply by the derivative of 4x minus 1, which is just the sum of two terms. So we take the derivative of 4x, which is 4, the derivative of 1, which is 0. But then don't forget we're using the quotient rule. So we have to multiply all that by the numerator, so 2x cubed. And then the quotient rule says to divide the whole thing by the denominator squared, which would be 4x minus 1. Now how you write this is going to be to the fourth all squared. So you could indicate that in 2 steps, but if you have something to the fourth all squared, we just multiply the exponents. So this is just going to be to the 8th. Now this would be unsimplified form, and I talked about this on in a previous section, that it's important that you know how to take a derivative and leave your answer in unsimplified form. This indicates to me that you understand the rules that are involved. But often you'll be asked to simplify your answer. Simplifying your answer involves taking out common factors. So I'm going to do that for you just to show you how that would be done. So to simplify this, what I would do, this minus sign is separating a series of factors. There's 2 factors here and a whole bunch of factors here. So I look at this minus sign as being the distinguishing part. And what I ask myself is there anything common? So here I have the number 6. Here I have 4 times 4 times 2. Well, the number 6 is 2 times 3. So I could remove a 2 from here, and I could remove a 2 from here. So I can take the 2 out as a common factor. There's an x squared, and here there's an x cubed. Those are also factors. Think of the x squared as just x times x. This is x times x times x. There's 2 common factors of x, so I can remove the x squared as a common factor. And then I move on to my binomial, 4x minus 1 to the 4th, 4x minus 1 cubed. I can take out 4x minus 1 cubed. Those are all common factors. I then draw a large bracket to indicate that I've removed those common factors. And what I'll be left with, there'll still be a 3 here, and there'll be one of these. So I'll have 3 times 4x minus 1, subtract. And from here I've taken out the 2, so I'm still left with 16, 4 times 4. I've taken out all of these, but there's still an extra x left over. All of that is being divided by 4x minus 1 to the 8th. Now, if you can reduce, you should, and you'll often be able to reduce when you use the quotient rule. You'll notice that there's a common factor of 4x minus 1 cubed in the numerator, and there's 4x minus 1 to the 8th. So I can divide all of these out with 3 of these, so I'll be left with 5. And then we just tidy up this bracket. So we're going to end up with 2x squared times, now inside this bracket here, we have 3 times 4x, which is 12x, take away 16x, so we have minus 4x. 3 times minus 1 is minus 3, all over 4x minus 1 to the 5th. And this answer right here, this is said to be simplest factored form. Now you'll notice that there's a negative in both of these, so we could take the negative out. It's really not essential, but if you want to make it look a little bit nicer, we could go negative 2x squared times 4x plus 3 over 4x minus 1 to the 5. On an exam, this would be perfectly acceptable. This is just a person could make an argument for this looking a little nicer, but either one is considered to be in simplest form. So this is unsimplified form. This is telling me that you understand the rules of differentiation. This is showing me that you have the algebra skills required to take an answer and write it in what's called simplest factored form. So for our next example, I've set up a function, f of x equals 2x plus 3 in brackets times the square root of 5x minus 1. Again, a combination of differentiation rules. The key is to identify the dominant function. 2x plus 3 is a function. It's a linear function. It's just 2 terms, 2x plus 3. But that function is being multiplied by another function, an algebraic function, the square root of 5x minus 1. Since these 2 functions are being multiplied together, the product rule is the dominant rule. We can't get rid of the product rule. We cannot multiply these together. We can't distribute into the radical sign. So what we have here is the dominant rule being a product rule. So the product rule says that to take the derivative, in this case would indicate it by the symbol f prime. The product rule says that we start by taking the derivative of the first function. If you like, a little trick you can use is you can just call them p and call them q. The product rule says that if you have p times q, where p and q are functions of x, then the derivative is going to be p prime q plus q prime p. I find some students find it helpful if they actually will go off to the side here and just, they'll write p equals 2x plus 3, q equals root 5x minus 1, and then just differentiate them separately and then plug them into your formula. Or you can just work through it as you go. So the derivative of p. So p is just a sum of 2 terms, 2x plus 3. So the derivative of 2x is 2. The derivative of 3 is 0. But that must be multiplied by q. So that's multiplied by, now I'm going to change this to an exponent because we're going to have to at some point. That way I'm consistent. So this is going to be times 5x minus 1 to the 1/2. You don't have to. You can leave it as a root sign. It's just that we're going to have to change it to 1/2 to take the derivative. So that way everything is just with exponents, not a mixture of exponents and radicals. The product rule then says to put a plus sign, and then you take the derivative of q. Well, if you look at q is our general power rule. We've got a function of x being raised to an exponent. So the general power rule says multiply the exponent out front, don't do anything inside the bracket, subtract 1 from the exponent, so 1/2 take away 1 is minus 1/2, times the derivative of what's inside the bracket, which is 5x minus 1, which would just be 5. And then, of course, we're using the product rule, so we have to multiply by 2x plus 3. Again, that would be the answer in unsimplified form. We could, it's a little more difficult taking out common factors because of the fractional exponents, but we could. I don't want to go through this with every single question with you. I think it's more important at this point that we just practice taking derivatives. The simplifying part will come with practice and with experience, and we'll just leave it at that. So this would be the derivative in unsimplified form. But a combination of product rule, power rule, general power rule, our sum rule. So basically, to do a question like this one, you're having to take the derivative of a function using a whole variety of different rules. We'll maybe try another one here. Something like y equals 3 over 2x plus 1 to the 5. I've selected this question because this is something I talk a lot to about my students. Even though this question looks like a quotient, we have a function over a function, never confuse a constant with a function. One of the most important rules you have in calculus is that if you have a constant and a function, like 5x, 5 times x, you don't treat it like a product rule. You just treat it as a constant times a function. Well, same thing here. Don't treat this as a quotient rule. What I would suggest you do is you change the question to 3 times 2x plus 1 to the minus 5. Now, I would never do that if this was a function. If this was 3x over 2x plus 1 to the 5, moving it up to the top, yes, I got rid of the quotient rule, but then I'd have a product rule. And I don't see them as being any separate. Product rule, quotient rule, they're about the same level of difficulty. But now what I've done is I've eliminated the product or the quotient altogether. Now I just have a constant times a function being raised to a power. This is just my general power rule. So to take the derivative, dy dx, the general power rule says just multiply the power out front. So negative 15 times 2x plus 1, subtract 1 from the exponent, multiply by the derivative of what's inside the bracket. There's your answer in unsimplified form. There's not much that could be done here to simplify this, but if I did ask you to simplify it, you could multiply 2 times 15 and go negative 30. And then most people like to move negative exponents to the bottom. So you could go negative 30 over 2x plus 1 to the 6th. I would accept on a test the answer to the negative 6. I personally don't see where one is any better than the other. It's obviously nice if you understand that they're both the same. Moving it to the bottom, leaving it at the top, it's just personal preference. Okay, and maybe we'll just do one more. I guess the last thing I'd like to show you is make sure you understand that something that I really stress to my students a lot is before you start taking a derivative, ask yourself, is there any way you could simplify the question? For example, in this one right here, moving this up to the top, I believe made the question a lot simpler. Another thing that you might see is something like f of x equals, and then let's say you had the square root of x times x squared plus x cubed. Now on the surface, this looks like a quotient rule. A product rule, because we have a function. This is not a constant. We have a function, root x, being multiplied by another function, x squared plus x cubed. If you did use the product rule here, the question would get really messy because of the fractional exponent. What I'm suggesting in a question like this one is, because there's no power on this bracket, why not just change this to x to the 1/2, And then if you can eliminate the product rule, you should eliminate it. In this case, we can. We have rules that allow us to multiply exponents together. If you multiply x to the 1/2 times x to the 2, you add the exponents. So this will become x 1/2 plus 2 would be 5/2 plus x to the 7/2. Now the whole point of me selecting this question is we haven't taken a derivative yet. All we've done is applied some rules of algebra. But I think it's a lot easier to take the derivative of this function than it is of this one using the product rule. So now our derivative, f prime, is just a combination of the power rules and our sum of two functions rule. So we would just take the derivative of this one by multiplying the exponent out front, subtract 1 from the exponent, so to the 3/2, plus 7/2 x, subtract 1 from 7/2, you're subtracting 2/2, so we end up with x to the 5/2. And the last thing I'd like to make a comment on about this question is there's absolutely no reason to change this back to its radical form. I personally would leave the answer like that. If you wanted to, you could write this as 5/2 square root x cubed, changing the 3/2 back to a radical. I really don't see a point in doing that. I think this is easier to work with. It's easier to remove factors from if you have to. And so I personally would just leave it as its exponential form. Again, we could do the same thing with this one. Change it to the square root of x to the 5th. So we're done. All the rules of differentiation that you're going to see at this point. Now it's just a matter of practice. So hopefully you can take the opportunity to do as many questions as possible to try to master these rules, and especially when they're used in combination, because you have to ask yourself the question, what's the dominant rule, and start from there and work your way inside the question.